Let's recap the main simulation. Since part 1 and part 2 are two sides of the same coin, I will recap them both here. In part 1, we saw how the prerequisites we created are used to feed into the final system. We have used various techniques thereafter to work on our final result. We have used packed geometry so we can control the building bounding boxes with a particle simulation. We have also used that same technique to represent our buildings as a single point at the end of the chain, with each point containing data to describe what building or which part of a building it is, using a custom building ID attribute, its rotation described by a normal and up vector, and its location relative to the city plan. We have used a number of grouping techniques, and we've used those techniques to select and remove unwanted geometry, buildings, and also to identify open spaces to fill back in. In part 2, we went ahead and automated the system we built in part 1. To do so, we used a wedge ROP to automatically change certain parameters and kick off a simulation for each city block. To support this process, we used Python for a number of things. To set switch nodes depending on custom attributes we created, for example to choose between commercial buildings or houses, depending on the city block type. To save us manually loading in each city block. Once done, we stored the disk location to which they were written into a file. We then used a list comprehension to parse over the data in that file and filter out duplicate entries. And the result of that operation we fed into a script executed by a button we created to load all those city blocks in with a single button click. Finally, we ended up with the entire city point cloud and again used custom attributes, in this case the original block position, to assemble it as desired. We are now ready to move on to the next module, in which we will build up our point cloud to describe full buildings and as such the entire city.